So this session, I'm focused on solving equations with cube roots, but the techniques that I'm doing apply to square roots, fourth roots, and all those sorts of things. But I picked cube roots because those are usually where students struggle. The square root part, they kind of get that. It's usually once you have higher indices on your radicals that it's like, wait, what do I do? So that's why I chose to do this. So, cube roots are also known as radicals. Any kind of root is called a radical. And we actually learned that in week 1. It was mentioned in section R.3. And then last week in section 3.1, we were learning how to simplify radicals. And we learned specifically the rule that if you have something like x to the n, and then you take the root with that same index, they essentially cancel out. So a square root cancels out a square. This actually also works in reverse, so that if you have a radical, you can square it. Like if you have a square root, you square it and it undoes it. So you can have the square on the outside, not necessarily on the inside. So if I write that, this would be also if you have like the nth root and then you take an exponent to it, those completely cancel out. And that's what we're going to be using this property when we're solving radical equations. And a radical equation just simply is one that has a radical in it, but what's specific is that there's a variable inside the radical. So you can have equations with like square roots, but if it's a square root of a number, it's not considered a radical equation because your variable isn't inside there. So whenever we're naming an equation, we look at where is the variable. And so if it's inside a radical, then it's a radical equation. So when you're solving these, your goal is you want to get rid of that radical. You know, if it's square root, cube root, whatever, we want to get rid of it. And so we basically do an exponent on both sides in order to get rid of it. So square roots cancel out things that are, or a square will cancel out square roots. If we have cube roots, then we cube both sides. The downside of this is sometimes we get extraneous solutions. These are basically extra solutions, but when you test them in the original problem, they don't actually work. So unlike other types of equations that we've been doing where you don't really need to check your work, you can, but it's not really required, like solving a linear equation or quadratic. With radicals, you do. You have to check your answer because you do frequently get extra solutions, and these tend to happen when you raise to even powers or even exponents. So if you square both sides or you do like the fourth power on both sides, that's when you tend to get extra solutions. So odd powers don't tend to do this. So cubing usually doesn't result in the extra solution. And the reason why this happens with even powers is because when you have something squared, you have like both a negative and a positive version inside there that can work. And so that's how you tend to get an extra solution, even though only one of those actually works. So always check your answers. And then the other thing you want to look out for is if you have a radical with an even index equaling a negative, because those have no solutions. So with odds, you can have like a cube root equal to a negative. That's completely fine. So there's some things to look out for here when you're solving radical equations. That makes them a little more complicated. So the basic steps for solving a radical is, your first step is to make sure that the radical is by itself. So you're going to have whatever your radical is equal to some junk. It could be a number, it could equal to a number plus variables, but it's just you've got to get that radical by itself, and you don't want to have a number in front of it because it makes things a little more complicated. So if you have like a 2 in front of a square root, you need to divide both sides by 2. Because otherwise, when you undo the square root, people forget that you have to square everything and then mistakes get made. So you don't want to have any variables or any coefficients, anything in front of that radical. Once you've got it by itself, then you're undoing that radical by figuring out what the indice is, or the index. So if it's square root, then you square it. Cube root, you cube it. So you're going to undo it, and you do that on both sides of the equation. And then you get another equation that you solve. And usually what happens, it's either going to be a linear equation or a quadratic equation. So once you've gotten rid of the radical, then you need to follow the steps for those other types of equations. And then you have to check your work. And you need to check it in your original with the radical, not after you've squared or cubed or anything like that. You always have to check it in the original for these types of problems. So that's the basic procedure. And so generally, to solve this, if you have a square root, you're going to square both sides. A cube root, you're going to cube both sides. Fourth root, do the fourth power, etc. So we're focused only on the cube root problems here because those are the ones that people kind of freak out about. So I'm only going to be doing cube root problems for my examples, but the process is going to be the same whether it's a square root or any other kind of radical. So from here on out, examples. So we've got the cubed root of 2x minus 1 equals 1. So, or 2x minus 5. I said too many ones there. Cube root of 2x minus 5 minus 1 equals 1. So just as a side note, whatever's underneath the radical, like we have a linear part that's underneath the radical, so we should get one solution out here. That's the general rule that I follow and that I have found to be true, though I have never actually seen this written down or proved, so I don't know if this is a firm rule, but I have found it generally to be true. So we're going to expect to get one solution out of here because underneath the radical is a linear piece. So to solve, we need to get the radical by itself. So we need to get this cubed root part by itself. So I need to get rid of the minus 1. So we start, and oops, forgot to mute my phone. So we're going to start by adding 1 to both sides. And accidentally changed my highlighter color, not the pen. So that gives us this cubed root of 2x minus 5 equals 2. So now we've got the radical part by itself, and to get rid of a cubed root, we're going to cube both sides. So that's going to make things to the third power. So that undoes the radical, and I'm left with what's underneath it. So we get 2x minus 5, and then 2 to the third power is 8. And then from here, we just have a linear equation to solve, and we're going to get one answer out of here because it's linear. Linear means one solution. So now you just solve for x, which is, fairly straightforward. So we'll add 5 to both sides. And you are welcome to do this at the same time. 8 plus 5 is 13. So we have 2x equals 13. And then we divide both sides by 2. And you're going to leave your answer as a fraction. We have 13 over 2, which doesn't reduce. So you leave your answer as a fraction unless specified otherwise, and just generally in math, we just always leave things as a fraction. Now we need to check our answer just in case this is actually an extra solution, and there's no solutions to this. So you always have to check your work. So we just solved, we got 13 over 2 for x, so I have to plug that into my radical equation. So that's going to be 2 times 13 over 2 minus 5, then minus 1 equals 1. So 2 times 13 over 2, the fraction there cancels out. And so we're left with 13 minus 5 minus 1 equals 1. 13 minus 5 is 8. So we get the cubed root of 8 minus 1 equals 1. So 8 is 2 cubed, so the cubed root of 8 is going to give you 2. And if you have a calculator that does cubed roots or other kind of roots, that is going to be very handy because usually people don't really know their roots very well. But that will then give us 2 minus 1 equals 1, and 2 minus 1 is 1. And so this check works. And so this is our solution, 13 over 2. Now, let's say you're not good at cubed roots and stuff, and you're like, okay, I don't really know how to do this on my calculator. So I'm going to just bring Desmos over and, of course, the scientific calculator. So if you're really struggling, this is the button that you can use for cubed roots. So when I click that button, it automatically puts me up in the index here. So I can type a 3, and then I can put my number underneath here, 8, and then that will give me 2. So if you have like a handheld calculator and you're not really sure how to use it, you can use this Desmos calculator. The other thing that I frequently do with my calculator is instead of using that root button, if I can get it to hit enter, maybe I want to get a new line. There we go. So another alternate way is that when you do a radical, it's the same as the 1 over n power. So a square root is a 1/2 power. So if you don't have a button like this on your calculator, you can instead do an exponent. And in this case, this is the button to get the exponent up here. And then you would want the 1/3 power. So you can even hit the fraction button here. And 1/3 is the same as the cube root. So if you don't know how to use the root button, like usually there's a square root button. If there's like an nth root, cube root, fourth root, the button's usually a little harder to figure out. So you can alternatively use your exponent button, and then you just do 1 over whatever that root is, and that's equivalent. So I actually frequently on my calculator do this versus the root, because the root button on my calculator I get confused with how to use. So I usually just do the exponent button instead. So just a side note for that. That will make checking your work a lot easier. And again, with fractions, you can use the same thing, use your fraction button. So that way when you're checking your work here, you're not fighting with the arithmetic, because I want you to focus on the solving part, not the checking your work and like making sure you can do all that, although that is good for checking your work and make sure you've got the right answer. Are there any questions on this example? Okay, so next example here, we've got 2 cubed roots. And this one is actually nice to solve because it's equal to 0. If it was equal to something else, like a number or whatever, it could potentially make things really gross. But when you have something equal to 0 and you've got like 2 different radicals, your goal is you want them to be on opposite sides. So you don't want to have them on the same side because it will make things really difficult to solve. You need to put them on opposite sides. And this applies if you have square roots, any other radicals. So if you've got an equation with a radical, you want them, and you have more than one radical, they need to be on both sides. So what we're going to do is add the second one to both sides so that they're on opposite sides. So I'm adding the cubed root of 4k plus 1 on both sides. And so we end up with the cubed root of k minus 8 equal to the cubed root of 4k plus 1. And we basically, you want to have one of the radicals isolated, or in this case, both of them are. They're by themselves. And so now we're going to cube both sides. And this works out really nicely because it cancels out on both sides, because they're essentially equal to each other. And so we end up with, if I can get my white, k minus 8 equal to 4k plus 1. So it's actually really nice to solve this way. It looks more complicated than it is. You just have to make sure they're on opposite sides, and then they both cancel when you cube it. So at this point, we're just solving for k. So I always like to put my variables on the left. You can do whatever you want. That's just my habit. So I'm going to subtract 4k from both sides. So 1 minus 4, I get a negative 3k minus 8 equals 1. Then I will add 8 to both sides. I get negative 3k equals 9. And then when we divide both sides by negative 3, I get k equals negative 3. So now we have to check our work just to make sure that we didn't come up with an extra solution here. So I need to put negative 3 into my original problem. So the cube root of negative 3 minus 8 minus the cubed root of 4 times negative 3 plus 1 equals 0. So we're going to have a lot of math to do here. We have cubed root. A negative 3 minus 8 is negative 11. Then I have a minus. And then I'm going to have my cubed root. 4 times negative 3, that's negative 12 plus 1 equals 0. And then I've got the cubed root of negative 11 minus the cubed root. Negative 12 plus 1 is negative 11 equals 0. So we've got the cubed root of negative 11 minus the cubed root of negative 11. Those cancel out. I know it's kind of confusing what we're looking at here because we've got these numbers underneath here, but those actually add up to 0. Like when I first look at this and I've got all these negatives and all these like radicals going on and I'm like, what does this equal? Do those cancel out? Do they not cancel out? These cancel out and we do end up with 0 equal to 0. So that does mean that our answer of negative 3 works. Now, to save yourself time on checking your work, especially with something like this, I'm going to bring up Desmos again, the scientific calculator. And instead of going through all of this stuff on the left, checking by hand, and it's just going to be kind of gross, you can put in this whole first line and let it do it for you and see if that equals 0. So I'm going to use my radical button here and put in 3. And then I've got negative 3 minus 8. And then I have to make sure I hit my arrow so I'm outside of the radical symbol. So you have to pay attention to where your cursor is. And then a minus, so good, my minus is outside the radical. So you got to be very careful about that, especially if you're putting things in ALEX. You got to make sure where your cursor is. Then I've got my cubed root, then 4 times negative 3 plus 1. And so you can see that that equals 0. So instead of, if you're trying to check your work, it might be quicker just to use a nice calculator like this where you can just type in everything and then it will tell you that equals 0 and good. That's what you want. especially at a quiz, checking your work this way is a lot easier than doing it by hand. You just have to make sure you're actually plugging in the right numbers and typing in everything correctly. Because if I like forgot a negative sign or something, like if I accidentally made that a 3 instead of a -3, it doesn't give me 0. And then that could be like, oh no, did I make a mistake? But it's just I plugged it in wrong. So just a good way to check your work that can save you some time, and even do this like on, even when you're working through the homework, this is a good way to check your work versus having to go through all of this by hand, because it can be time consuming. Any questions? Okay, so next one here. Now notice that it says k plus 18 to the 1/3 power. This is still a cubed root. I mentioned before that if you don't have like a radical button, you can do 1 over the whatever the index is. So even though this is 1/3, it is the same thing as a cubed root. It's just written differently. But the same rules apply. We want to get that radical part, or in this case, the part with the 1/3 exponent, we want to get that by itself. So we're going to subtract 5 from both sides. So don't let the different exponent kind of throw you off, because it really does mean the same thing. And if it's a 1/2 power, that's a square root. So we have k plus 18 to the 1/3 power, and then 3 minus 5 is -2. It's okay to have an odd root equal to a negative. So if this was like 1/2, that would be a square root. Square roots can't really be a -2 like that. You can't have that. It'd be imaginary. But in this case, this is okay because it's odd. It's 1/3 and 3 is odd. So we can have it equal to a negative. And so we're following the same rules that we did before. We want to get rid of the 1/3 power. So we do the exponent of 3. You're basically doing the reciprocal exponent. And some people may find, instead of doing your work with the radical symbol and the cubed root symbol, that maybe you prefer to write it as a 1/3 power instead. It means the same thing, and it may make more sense as to why we're cubing both sides. Because if you look at your rules of exponents, 1/3 times 3 is equal to 1, and that's why the exponent disappears. So it may make more sense to you if you write it as a fractional exponent instead of using that radical symbol. So on the left we have k plus 18. Now on the right, -2 to the 3rd power will give me a -8. So if it's an odd exponent, your number is going to stay negative when you do the power. If it's an even exponent, the negatives cancel out. So that gives me a -8. And then this is pretty simple. From here, we just subtract 18 from both sides. Not too bad. And then we get k equals 18, 18, 16, -26. Assuming I did my mental math correctly, and I'm going to just do it on a calculator just to verify that I didn't mess that up. Okay, -26. So not too bad to solve, and now we just need to check our answer. So I'm going to plug in -26 for k. So we have -26 plus 18 to the 1/3 power plus 5 equals 3. So -26 plus 18 is going to give us -8. So we have -8 to the 1/3 power plus 5 equals 3. And so that is the same as taking the cubed root, but you can also do the 1/3 on your calculator like that, like I showed on Desmos. If we bring up, like here we have 8 to the 1/3. If you're going to do -8, you do have to have parentheses around it before the exponent to properly do that in your calculator, because otherwise it will give you potentially the wrong answer. So -8 to the 1/3 power is equal to -2. So we have -2 plus 5 equals 3. And then -2 plus 5 does actually equal 3. So far, none of these have had extra solutions. And like I said, things with odd exponents or odd radicals tend to not have extra solutions. It tends to be the ones where you have evens where you tend to get the extra solutions. And, you know, I have not seen that proven anywhere. It's just something I have noticed in all the years I've been doing math. Any questions? Okay, so I have 2 more, and these are going to be a little different because they're not 1/3 or a cubed root. It's a different exponent. It's here I've got 2/3. We have 5t to the 2/3 equals 1/5. So just as a kind of a side note of what that means, t to the 2/3 is equivalent to if we had t squared to the 1/3 power. So this would be the same thing as if I had the cubed root of t squared. So it's still a radical equation, it's just written a little bit differently. So if it helps, you can rewrite that t to the 2/3 in its radical form so you can really kind of see what's going on here. So if we do that, we'll have 5 times the cubed root of t squared equals to 1/5. So when we're solving this, we want to get our radical part by itself. So you want to divide both sides by 5, because if you try to cube at this point, you have to cube the 5 and the cube root part, and it gets kind of messy and prone to mistakes. So first thing is dividing both sides by 5. And so having a calculator that can do things with fractions, you know, it just makes your life easier. So I've got the cubed root of t squared, and I'm going to get 1/25 when I divide 1/5 by 5. So now I want to get rid of the cubed root. So I'm going to cube both sides. Now notice under the cubed root I have a t squared. So I'm going to get 2 solutions out of here. So because of the t squared, there's going to, you know, I'm going to have to solve a quadratic equation. So we end up with t squared, and then if you want to do 1/25 cubed on your calculator, it's basically 1 cubed over 25 cubed. And it's going to be this kind of really gross looking number. It's going to look like this. I am actually going to write it as 25 cubed. Just for now. Because it will just make things, you know, it's easier than writing that big number. It's going to be 1 over than this 25 cubed deal. And now we have a t squared, so now we need to take the square root of both sides. Because now we've got to get rid of the square, we need to solve by taking square roots. So I need to now kind of undo everything because of that square there and take the square root of both sides. And this will give me a plus or minus, because whenever we solve something with square roots, so I'm going to get a plus or minus, and that square root cancels out the t squared. And then I've got this 1 over 25 cubed. And we need to kind of simplify this whole 1 over 25 cubed deal. So here's a nice little trick. 25 is 5 squared. So this is the same as 5 squared and then cubed. You can actually interchange these exponents because you would just be multiplying the exponents together and you can change the order of multiplication. I didn't actually interchange those. I wrote the same ones. I meant to interchange them so that you have the cubed in the middle and then the square on the outside. And when you do this, you see, oh, that square root is canceling out the square that I have right there. So this is going to give me plus or minus 1 over 5 cubed. And 5 cubed is 125. So this is going to give me two answers, a positive and a negative 1 over 125. Now you may find that this is sort of a complicated way to solve this problem. It's kind of confusing. You know, it looks confusing. So there is an alternate way that we can solve this problem. And I thought I was going to have enough room to do it on the same slide, but I'm not. So alternatively, so I'm going to start with what I had. 5t to the 2/3 equals 1 over 5. So I'm not actually, I'm going to start with that original problem. Make that look better. And we're not going to rewrite a radical. We're going to go straight to trying to get the exponent part by itself. So we're going to divide both sides by 5. So this gives me t to the 2/3 equals 1 over 25. I want to get rid of the 2/3 power, and so we're going to raise it to the reciprocal. That's the same thing that we were doing before. When we had the 1/3, the reciprocal of 1/3 is 3. So we're going to raise it to the reciprocal. And that will cancel out my 2/3 power. And we're going to get just t. Now on the right side, you're probably wondering, well, what are we going to get here? And this is where your calculator really comes into handy. So I'm going to bring up Desmos here, just get a new line, and I'm going to do 1 over 25 and then I want the 3/2 power, and then it gives me this decimal, but at least I can convert it to a fraction. It gives me 1 over 25. I think this is a much easier way to solve this because now I know, okay, t is equal to, and I got 125. Now here's the thing. When we did it this way, using Desmos here, we got basically one answer. But when we solved it with the other way here, we got a plus or minus. So what is correct? Well, we need to check our answer. So in here, we need to check both the positive and the negative. So if I check the positive version, 1 over 125 to the 2/3 equals 1/5. So I'm going to use, again, Desmos to make my life easier here. So I'm going to type in 5 1 over 125 in the exponent to, oops, thirds. And then, okay, that equals 1/5. So that works. I'm going to put a little check mark. And then we need to check our negative answer. So I'm going to bring up Desmos. And I'm going to, basically all I have to do is need to change that to negative. And then you see that we also get 1/5. So the negative is also working. So both of these solutions are correct, positive and negative 125. So now if we compare that to solving this way, we only got one answer. We missed an answer. It's easier to solve this way, but we missed using our calculator that there's also a negative. So the basic rule is, if you're using this method and you see an even number in the denominator, always do a plus or minus. So if you're using this method where you're raising it to the reciprocal instead of rewriting it as a radical, if you see that denominator as an even number, always make a plus or minus. So that would give us a plus or minus here, because your calculator doesn't do that. Your calculator just assumes it's the positive answer. And it's the same thing if you take a square root of anything on your calculator. It assumes only the positive. It doesn't give you the negative. So that's just a kind of a side note here, that these types of problems you can solve with the radical version or the exponent version, but you do have to do some thinking, because otherwise, if you just do it blindly and you don't think, or you don't realize what does this mean, you could potentially miss a number if you miss that plus or minus. Doing it this way doesn't miss the plus or minus, because we know when we take square roots we have to get a plus or minus, but it looks a lot more complicated, and it definitely took more steps. So I'm going to just throw up a poll to ask, which method do you prefer? And so the first method would be to rewrite it as a radical. And then the second would be to leave it in exponent form. So that should show up on your screen. You know, basically I did this problem both ways, and I'm just curious which way you prefer. Or maybe you don't know yet until you do a lot of practice. Second way seemed easier to solve, but yeah, still complicated. Yeah. Yeah, I prefer the second way, but you just have to remember the plus or minus. So I'm going to do this one the second way then, just to kind of, you know, indicate, okay, we got to remember this plus or minus deal if we're going to solve it the second way. So we've got 3, and then in parentheses, x minus 6 to the 2/3 power equals 48. So we need to divide both sides by 3 first, as we want to get that whole exponent part by itself. And I don't want any numbers in front because it just makes it more complicated. Okay, so I've got x minus 6 to the 2/3, and then 48 divided by 3, I should know, but off the top of my head I don't, so 16, using my calculator. So we're going to raise both sides to the reciprocal 3/2. And then because we have that 2 in the denominator, we're going to have a plus or minus in our result. So you maybe, if you're going to use this way, write that note, you know, or maybe circle it or something like that. you know, just something that means we're going to get a plus or minus here. And I think only one of these is going to be the correct. I'm trying to think. No, maybe both will work. I'm trying to guess ahead. Maybe I just shouldn't even do that. So we're going to get an x minus 6 and then plus or minus, and it's basically 16 to the 3/2 power. And I'm going to just use Desmos to figure out what that is. So I like to rewrite my plus or minus before I actually do this thing, just to remind myself, okay, I got a plus or minus here. So 16 to the 3/2. Okay, so that's going to give us a plus or minus 64. So x minus 6 equals plus or minus 64. Now we need to solve for x, and because of the plus or minus and we've got a whole number, this is where I'm going to write two separate equations. So one where it's x minus 6 equals 64, and then x minus 6 equals negative 64. And then I'm basically going to be adding 6 to both sides for both of these. So I like to do that at the same time. Get x equals 70, and then x equals negative 58. Make sure I'm doing that right. Yes. And now we need to check both of these answers to make sure they work in the original problem. And sometimes, like, what I will do when I write my check is I'll first write down what the x value was that I plugged in, just as a reminder. And so I'm going to put the left side into Desmos and then see if that comes out to 48, because that's more math than I really want to bother doing. We just want to make sure that this works. So I have to have my 3 parentheses 70 minus 6 close parenthesis exponent fraction 2/3. Okay, 48, good. So I know that that is for sure one of our answers. And then we need to check negative 58. So it's going to be negative 58 minus 6 inside of the parentheses, 2/3 equals 48. So the nice thing about using Desmos, especially if you're at a calculator, is all I have to do is just change that number. Then it will do it for me. It really does save some time. I would bookmark this website, you know, use it all the time. And you can see that that also comes out to 48. So that also works. So we have two solutions here. And again, like I said at the very beginning, that when you have odd roots, or in this case, an odd number in the denominator of like a fraction as your exponent, you don't tend to get extra solutions. It's when it's an even in the bottom of the exponents that you tend to get extra solutions. Whoops. Oh no. Oh. I somehow hit a button, but it saved. Somehow closed the slideshow. Don't know how I did that. What I wanted to do was just to go back again to the very beginning to kind of, you know, refresh. So your goal is to basically get rid of your radical by raising both sides to an exponent that will undo it. Sometimes you get extraneous solutions, but as I said, they tend to occur when you have something, when you have to like square, when you have an even exponent there. Because we were doing all things with cubed roots, we didn't get any extra solutions. And so you should always check your answer, but generally it's more important if it's going to be an even power. So if you're running out of like time on a quiz and you have a cubed root, then don't bother checking your answer. You know, but if it's a square root, yes, definitely check your answer. Are there any questions? All right, so um, that is basically solving cube roots in a nutshell, and the techniques that we did apply for if you have square roots or any kind of fractional exponent. You know, you could see 4/3, you could see 1/5 or whatever. The same general techniques work for those. I know a lot of people see square roots as different from cube roots and fourth roots and everything, but they really are the same step. And I think looking at it as terms of a cube root kind of helps you understand that the same stuff happens with the square root. So hopefully this helps. I know solving radical equations really get people really confused. I know, Tina, you had said you were getting confused about this, so hopefully this has cleared up any issues you're having. And if you guys are running into issues when you're doing the homework in Alex or something and you're like, I just don't know what I'm doing wrong, take a picture of your handwritten work and the original problem and like email it to me or send it to me through Remind, and I can usually take a look and see. Usually it's just an error in, you know, a negative sign, or maybe you did something out of order. That's usually what the issues tend to be. So I'm going to let you guys go. And just as an FYI, because of the holiday coming up on, you know, July 4th is a Sunday, Grantham observes it on Monday. So Monday I will not be checking my Grantham email or anything like that. I'll still be on my phone with Remind, but I'm not going to be like officially checking my email. And I'm not going to be having my office hours on Monday as normal, because that's going to be my day off. So just an FYI about that, but I'll have my normal office hours as usual. So actually my Sunday office hours, which are usually 6 to 8, I'm actually going to do Sunday 2 to 4 instead, just because 6 to 8 I'm going to be at a barbecue for the 4th of July. So just an FYI about that. Those are going to be moved to Saturday 2 to 4. I should make a note to send an email about that. So I will do that right now. Just a note, send an email, send that out tomorrow. Okay, well, I'll let you guys go. I'll send out the presentation tomorrow along with the video, and I will see you guys next week, and hopefully you have a happy 4th of July and get to have some fun. So take care.